Hello everyone, this is Rashmi Shivanadhuni working as an assistant professor in Mlritm of department CSM. So today I have chosen the topic ADALINE and the MADALINE from the course Soft Computing. So firstly we need to know what is meant by ADALINE. So the name is different, but the short term was like Adaptive Linear Neural Network. So it's a network with a single linear unit is called as ADALINE, so adaptive linear neuron. So where a unit with a linear activation function is called as linear unit. In ADALINE there is only one output, so output can be of the bipolar. It is like +1 or the -1, and the weights between the input and the output units are adjustable. Like we can adjust the weight by using the old weight, where it uses the delta rule. Like we have the formula here: weight of new equal to weight of old, plus where we have the predicted output and also the targeted value, the true value. So computing of all these values, we can get the new value, that is updated value of the weight. So where wi is the weight and yin is the predicted output, and the t is nothing but the true value here. So we're coming to the part of learning rule, where we are using the rule to minimize the error, or else we can say here we are using the mean square error, like where it is going to give the computation between the activation and the target values here. So ADALINE consists of some trainable weights, so which are actually compared with the actual weights and with calculated with the output. So based on this algorithm, it is going to apply. So if you see the diagram of the ADALINE where we have the workflow, so here we have inputs like 1, x1, x2, x3 and x4. For every input values, where weights are carried through the layer. After carrying the weights, where net input function is going to compute, then after activation function has been taken to the consideration, and after the computation of the activation function, the predicted value is going to be displayed. So when if the weights or the predicted output is not as a clear, or we can say the precise one, so where we have the error part, where it's going to calculate or we minimize the error through the desired output. So firstly calculate the net input to your ADALINE network, then apply the activation function to the output, which is compared with the original, and if both are equal, the given output is output, or else if you get the error, back to the network and update the weight, and according to the error is going to calculate it by the delta rule here. So already we discussed new weight equal to old weight plus targeted value minus true value minus expected predicted output. So this is how we are computing the ADALINE. So coming to the part of training methods and algorithms, in ADALINE we are using LMS rule. So LMS is nothing but least mean square algorithm, which is taken as a primary algorithm for the ADALINE, which are also known as the Windroff Hoof's rule, where it is specially taken for the gradient descent method to minimizes the mean square between the desired output and the network input. So how the computation is going to be taken place? The first one, initialize. How we are initializing? Nothing but we are going to set the weights and the biases to small random values, that is nothing but non-zero values, and also we are going to set some learning rate to that. Then we are going to the second step, that is forward pass. For each training pair, we are going to set some input activations here, that is xi. Computing the we are going to calculate the output through the if you look into the formula, this is a formula where yn, that is predicted in output, plus bias. So this is how we are going to calculate the output. And also we can update the weight. That is the next step. Update the weights and the biases using the error like t minus yn, where here we are going to calculate the error value, and also we can update the weights and the biases through some displayed formulas. Then after moving to the next step, check for convergence, nothing but repeat until the highest weight is changed to the smaller, which is the specified tolerance for that. So moving to the next topic, that is MADALINE, multiple adaptive linear neuron, so which is a supervised learning. And also it consists of many ADALINEs in parallel with a single output unit. So as we know, in artificial neural network we have the three layers. The first layer is the input layer, second is the hidden layer, and the third layer is the output layer. In MADALINE, as we have the input layer, hidden layers, and the output layers. But particularly in MADALINE, instead of using some other layers or the hidden layer, we are using ADALINEs for that. So ADALINE is present between the input layer and the MADALINE. Hence, ADALINE layer is taken as a hidden layer. The weights between the input layer and the hidden layer are adjusted, and the weight between the hidden layers and the output layers are fixed. So here mostly we are using the majority vote rule. Nothing but the output could be an either true or false. So the ADALINE and the MADALINE layers neurons have the bias 1, which is connected to them, and also it is going to be have the problem with the non-linear separability. So this is a structure where we have the x1 and the x2 as the input, and also we have some biases b1 and b2, and we have the hidden layers like z1 and z2. We have the output layer, nothing but we are going to get the output through the yn actually. So where we some in this architecture it was considered some values with that, where how we are taking the values of weights like w11 w22 as it was mentioned here. So these are the three types of layers present in the MADALINE. First input layer contains all the input neurons, and the second hidden layer have the ADALINE layers, and the third layer having the weights between hidden layer and the output layer, which is nothing but fixed. They are not adjustable. So while early ADALINE network is specially trained by propagation with the especially with the propagation rule, which is nothing but MADALINE rule 2, where it is a supervised learning algorithm for training layered networks of ADALINEs. And also we can say it is based on the minimal disturbance principle, where it is going to correct the errors for the specified input pattern. And also I can say the distributed networks responses to each other, where it is going to correctly classify the pattern as possible. And also this algorithm will give the performance of the sequence of the adaptations to correct the output errors. Moving to the application, we have several applications on ADALINE. So firstly, adaptive signal processing, where specially it is used for filtering the noise and also for echo cancellation part. The second one is the power systems, where it is going to measure the reactive power. So and also it is going to estimate the harmonics in the power systems, and also going to control the active power filters. Third one is the speech recognition and the weather forecasting. Here it is going to detect the patterns, and also it is going to give the appropriate weather reports on that. The fourth one is the diagnosis. For ECG, it is a good example for the ECG where it is going to analyze the waveforms from the ECG. Coming to the part of MADALINE applications, here also we have several applications on that. First one is the telecommunication. It's mostly and majorly used in adaptive filters to remove the echoes on phone lines. Nothing but we can say the disturbance or uh, the disturbance. Nothing but removing the echoes it is going to use. Second one is the formatical analysis. Now here it is going to determine the content of the drugs in the capsule, where the capsule is contained some limitation of mixing by composition, where it is going to detect how much drugs are supplied or the mixed with. Then signal language recognition, where it's going to have the part of science. And weather forecasting. The last one is a vehicle classification, where it is going to give them different signatures of different vehicle types. So it is going to identify which type of signal is passing, and if the user is using any kind if the user is facing any issue, they are going to get the solution from the MADALINE applications. So moving to the advantages, we have several advantages of using ADALINE and the MADALINE. So firstly, we want to talk about the ADALINE advantages. Nothing but the first thing, it is the most and the fast, efficient training algorithm, or we can say is a method where LMS is used for the simplest and efficient part. Next one is the guaranteed convergence, where for linearly separable problems, where it is going to work in to get the minimized solution by using this. And also um it is going to separate different kinds of patterns. Next one is the robustness. It can adapt to changes the input signal over the time. So based on the signals, it is going to change the input signal. If we are giving the signals, the signal is taken as the input. If we are giving the pattern on the based on the network, it is going to change as a network. So it is called as the robustness. Moving to the advantages of MADALINE, where we can solve non-linear problems, separable problems, where it is having the multi-layer architecture, which is going to tackle the problems with that a single layer. But ADALINE cannot do the non-linear separable problems, so won't give any solutions for that. It is having the good generalization, where the networks are trained with the good algorithms like MRI, MR2 solutions, and where it's going to give the correct responses and give the unseen inputs for that. Moving to the disadvantages, ADALINE. Firstly, we are going to talk about the ADALINE disadvantages. So it is limited to linear separable problems. First one. Second one, like we have going. It is not going to have any generalization on that. So firstly, limited to linearly separable problems, where ADALINE can only solve the way the classes are separated through the straight line. But moving to the MADALINE, where it is going to handle the curve shape also, curve shape separated classes. MADALINE disadvantages are complexity. First one is the complexity, and second one is the convergence issues, where the architecture and the training of MADALINE 2, so very complex, and I can say it's a single ADALINE than a single ADALINE. Convergence issues. Some algorithms were used but do not have any convergence to know the solution for that, and also it can be stuck in between of the complicated partial problem solutions. So this is about the ADALINE and the MADALINE. and also we came to know the disadvantages and advantages of that. If we talk about any example on this, so I have chosen one example. So I want to explain on that, like echo cancellation in telecommunication, nothing but the classic ADALINE application. So the problems comes when you speak on speaker phone, your voice comes out of the speaker, travels through the room, bounces off walls, and re-enters the microphone as an echo. This echo gets transmitted back to the person. So when you are talking to, so this comes under the confusing the conversation. So this is a problem which I want to explain on taken as an example to explain the solution for that, for the problem. So firstly, how it is going to solve. So how the ADALINE is going to solve here. So ADALINE is placed in the phone system as an adaptive digital filter. So here we are going to take the inputs, target, net input, and error, and update in the action. Firstly, inputs. So how we are taking the inputs, that is XI. So delayed versions of the original sound signal, nothing but the voice coming out of the speaker, it's taken as the input. For example, if we talk about X1, that is the input, X1 is the signal delayed for 1 millisecond, then X2 will be delayed for some other seconds, nothing but I have taken by 2 milliseconds, and so on, as and taken as the inputs. So coming to the target T, the actual echo signal picked up by the microphones. The next step is net input YN. So here the ADALINE have the best guess of what echo sound should it be at this moment. So it can, like, the input we are taking as an ADALINE. So it is best thing, it is going to identify which type of echo it is. So this is a best advantage with the ADALINE. So coming to the error, T minus Yn, nothing but the leftover echo signal it is going to calculate. Then moving to the update in action. So how we are updating the weights. Before we talked about the updation of weights, updation of biases. So here also we have some of the updations in the actions here. So how we are going to calculate. So this is a formula which I have taken for, so to get the solution for the error. Error equal to actual echo minus estimated echo. So this is how we are calculated for the echo part. Nothing but the error in the this telecommunication. Okay, it then updates its weights. So as we know, the new weight is calculated with the old weight plus true value minus predicted input. So then here comes WI, nothing but weight of new equal to weight of old minus error, which is already we got in the action, into delayed sound. So this is a formula where we are updating the weights of the sounds in the telecommunications. So over the times, the weights are perfectly models the room's acoustics, and also the Yin, nothing but the predicted input also became exactly equal to the echo. So here comes the error, which is going to drop nearly to zero, and the echo is cancelled out in the real time. These updates thousands of times per second and up to you instantly if you move to the different room. So this is how the solution has been taken for the echo cancellation in the telecommunications. If when you speak on the speakers, the voice will be come out of the speaker and travels throughout the room and bounces off walls and re-enters the microphone. So this is nothing but echo. To cancel the echo, to minimize the echo, we have taken certain inputs for that, and also calculated how to minimize the error for that, to minimize and also the cancellation of any echo sound. So using of ADALINE, it is going to identify which type of sound it is going to happen for echo in the echo. So this is a best part of the ADALINE. And also MADALINE having many advantages here. It is going to solve some generalization part in this. So this is how about the adaptive and the multiple adaptive linear neural networks. So thank you.